They say you can feel it long before you ever see it.
This is where cold metal and quiet drawings become living aircraft.
Step inside one of Russia's most restricted industrial facilities. The production line, where the SU-57 stealth fighter takes shape. From the first forged metal to the moment its landing gear leaves the runway.
The language is not words, but pressure, temperature, tolerance, and time. In this hidden world of steel, titanium, and advanced composites, even the smallest part carries the weight of years of engineering, trial, and refinement. Here, the soundtrack is a symphony of controlled power. Deep hydraulic presses push against resistant metal. Robot arms move with slow precision. Sensors blink in quiet, sealed rooms where composite structures cure in darkness. In the distance, a single test engine whines to life.
By thick concrete walls and carefully engineered silencers.
This is not a place of improvisation. It is a place of narrow margins and exact decisions. Route has already been rehearsed inside computers and design studios. On paper, the SU-57 is a fifth-generation multi-role fighter. In here, it is a vast interconnected workflow. Today, we enter the heart of that workflow. From the heavy forging shops, to the controlled assembly bays, to the flight line, the moment its landing gear leaves the runway. The story of this fighter does not begin under bright hangar lights. It begins decades earlier, in a different era of aerospace design. Earlier generations were defined by raw performance. This new subtlety changes everything. But the next era demanded something more subtle, reduced radar visibility. Advanced sensors that could merge streams of data into a single picture. Airframes optimized not only for speed and turning, but also for surviving in a modern, surveillance-heavy battle space. Within the center fuselage section, the internal bays are structured with precise, angled surfaces crucial for radar control and stealth capabilities.
Yet beneath the aerodynamic skin, it still carries the familiar demands: withstand violent G-forces, high temperatures, sudden maneuvers.
A complete rethinking of manufacturing itself. Designers could no longer draw anything they wanted. In this factory, we see the end of that long, invisible journey. Arrive at the loading docks outside the main assembly halls. Vast yards and warehouses handle the first stage, raw material reception and control.
Titanium, one of the core materials of the SU-57 structure, arrives as dense, dull gray blocks and cylinders.
Nearby, coils of aluminum alloy sheet wait to be turned into skin panels. In climate-controlled storage, composite materials rest in cold rooms. In climate-controlled storage, composite materials rest in cold rooms. Yet each roll carries a tightly controlled composition. Once laid into molds and cured, every incoming batch of material is logged, sampled, and cataloged, locked into digital systems that follow each piece through the production chain.
A titanium billet has a lineage, a history of certifications, and a defined path through this factory.
Here comes one.
Next comes the transformation of this raw inventory into shapes that hint at their final purpose.
The ceiling cranes move slowly overhead, carrying heavy dies and partially formed components as if they were weightless.
A forklift brings in a titanium billet, still cool, still formless. It disappears into an industrial furnace.
On the factory floor, we never see the exact settings, but we see the glow of the open door. There is a narrow window where the titanium is ready to be forged.
The press descends slowly at first, then with immense force. A block of material yields and thins. The billet is placed into a die that hints at its future, perhaps a landing gear support, perhaps a portion of the fuselage skeleton. Between cycles, operators move with practiced care. What we see is the choreography of muscle, machine, and metal. In another section, ring rolling machines take thick, heated titanium hoops and gradually expand them into large, precise rings.
Then, the forged shapes cool, and the noise of impact gives way to a cleaner, sharper sound. Cutting, milling, drilling.
Here, rows of computer-controlled machine tools handle the intermediate stage.
Multi-axis machining centers rotate and tilt workpieces under spinning tools.
A large titanium frame is clamped into a fixture, and a cutting head traces along its edges.
A robotic arm may swap out cutting tools as needed.
Next, coordinate measuring machines and laser scanners move silently across the finished surfaces,
comparing the real part against the digital standard.
Composite forming rooms resemble laboratories more than traditional factories.
Each strip follows a prescribed orientation, building up layers that will act together as a single structural element once cured. Then, the molds enter large autoclaves, sealed pressure vessels where heat, pressure, and time combine to sensors record each cycle, ensuring that nothing deviates from the prescribed envelope. When the doors finally open, the parts that emerge are aircraft surfaces, light and stiff, almost impossibly smooth. As machining and forming progress, the factory begins to resemble an aircraft plant rather than a metalworks.
In one area, the forward fuselage structure comes together. Machined frames, ribs, and longerons are set into precision jigs.
Riveting, fastening, and bonding processes, each carefully controlled, bind the components into a single, load-bearing shell.
Nearby, the central fuselage section takes shape, a dense, multifunctional volume.
Next, the wings, with their blended root sections, grow in their own dedicated area. Their internal ribs and spars are assembled first. Then, skins are attached, and control surface hinges are integrated. Throughout these stages, digital models guide the flow. Any variation or misalignment can be checked against the model.
As subassemblies reach completion, here, the SU-57's silhouette finally appears. First, the central spine of the aircraft is established. Tolerances here are unforgiving.
Then, the wings move into place. Sensors and laser trackers may monitor the process. This is when the hidden systems move in. Wiring harnesses, hydraulic lines, fuel plumbing.
Hydraulic manifolds, reservoirs, and actuators find their homes deep within the structure.
Next, the power plant domain joins the main airframe. Engine mounting structures await the installation of the twin engines.
Engines arrive from a parallel production stream, and they are lifted and guided into position.
Around the engine nozzles, specialized structures are fitted to manage hot exhaust flow and overall thermal signature. Landing gear assemblies move into their bays. Their retraction and extension mechanisms are linked to hydraulic and electrical systems. Then, surfaces that will eventually meet the air directly are fitted and aligned.
Gaps are minimized and controlled.
Now, the assembled aircraft enters a deeper phase of testing and inspection.
Ultrasonic beams pass through composite panels. X-ray imaging examines complex joints.
Next, fuel tanks undergo controlled filling and draining cycles.
Hydraulic systems are pressurized. The landing gear cycles up and down, doors opening and closing in sequence. Electrical power-up comes in stages. With power applied, displays flicker to life in the cockpit. In anechoic chambers or dedicated test bays, selected sensors and systems may be exercised in controlled environments.
Towed to a static test area, dual systems are stressed under controlled conditions. Some airframes never intended to fly.
Now, attention turns to the engines. In a secure engine run bay, the SU-57 is anchored in place.
From the cockpit, follow established procedures to bring the engines to life. Air is drawn in through the intakes.
Gradually, power levels increase. The exhaust plumes grow denser, shimmering in the air.
Once engine runs are complete, taxi tests follow. It rolls slowly at first, checking steering response, braking performance. Finally comes the most symbolic step of all. The first flight of this particular airframe.
Thrust increases. The nose lifts. For the first time, this specific SU-57 leaves the pavement.
New billets of titanium enter the forge. In these halls, the SU-57 that takes to the sky is only